Okay, when the primary alcohol is oxidizing in the presence of chromium trioxide, we get aldehyde like CH3CHO. When primary alcohol is oxidizing in the presence of chromium trioxide, we get aldehyde, and it is known as the acetaldehyde. Acetaldehyde. Clear? Clear? Somebody answer me. Clear? Okay. Then we can replace the chromium trioxide by PCC. It is another reagent, PCC, and PCC is known as pyridinium chlorochromate. Okay, when the primary alcohol is oxidizing in the presence of chromium trioxide, we get aldehyde, and for the next reaction, we can replace the chromium trioxide as PCC, replaced by PCC, and the PCC is pyridinium chlorochromate. Clear? Then the second one, when I am oxidizing the secondary alcohol, the alcohol may be like CH3, CH3, secondary alcohol, so OH will be here. Oxidizing in the presence of the same reagents, that is chromium trioxide. We get the ketone CH3, CH3. Okay, look at the structure of the aldehyde and ketone. Aldehyde and ketone. What is it? CH3, C double bond O, and the other side is H. This CHO can be written as like this. Clear? And from here, the left side and right side are bonded by alkaline groups. One C double bond O is here, and left side and right side are bonded by alkaline groups. Clear? Clear? Anyone?
Yes, sir.
Okay. Then here also the chromium trioxide can be replaced by PCC. So when the primary alcohol is oxidizing in the presence of PCC or chromium trioxide, we get the aldehydes. And when the secondary alcohol is oxidizing in the presence of PCC or chromium trioxide, we get ketones. Okay, this is the first common preparation. It's called oxidation of alcohols. Okay, it's a common preparation for alcohol, aldehydes and ketones. And the second one. Second one is the dehydrogenation of alcohol. What is it? Dehydrogenation. Dehydrogenation. What do you mean by dehydrogenation? What do you mean by dehydrogenation? Dehydrogenation is the process of the removal of hydrogen. Dehydrogenation, that is the removal of the hydrogen. Clear? So it will be like when primary alcohol CH3, CH2OH, it is the primary alcohol, vaporizing in the presence of copper at 573 Kelvin. we get the aldehyde as CH3CHO plus what should be the byproduct? The byproduct is a hydrogen because it is the dehydrogenation process, the removal of hydrogen. So the byproduct is hydrogen. Clear? Clear?
Yes, sir.
Okay. So when the primary alcohol is vaporizing in the presence of copper at 573 Kelvin, we get aldehyde and hydrogen as the byproduct. The same way, we are taking the secondary alcohol, that is CH3, CH, CH3. So the secondary alcohol, the words will be like here. The same procedure, that is vaporizing in the presence of copper at 573 Kelvin. We get ketones, that is CH3, C double bond O, CH3. And what is the byproduct? The byproduct is hydrogen because it is a dehydrogenation process. Okay, clear?
Yes, sir.
And this process is also known as catalytic dehydrogenation. Okay, catalytic dehydrogenation. So if you are preparing for NEET, JEE, AIM, something like that, so please note down the names of the reactions also. Okay, this catalytic dehydrogenation process. So the catalytic dehydrogenation process is the process when the primary alcohol is vaporizing. The primary alcohol, this primary alcohol is vaporizing in the presence of copper at 573 Kelvin. We get aldehydes and hydrogen as byproduct. Here, usually the byproduct is not important, but in this case, byproduct is important because the question may be like this: the CH3, CH2, OH plus H2 at 573 Kelvin. Here it is X and here it is Y. What is X and Y? Okay, the question may be like this: what is X and Y? So when we know that it's primary alcohol. When primary alcohol, and from the primary alcohol there is a removal of what? Hydrogen atom. When the primary alcohol is removing or eliminating a hydrogen atom, it is dehydrogenation process. So the dehydrogenation process is under the preparation of which one? Aldehydes and ketones. And we know that this is a primary alcohol. So when primary alcohol is emitting hydrogen, here should be a aldehyde, CH3CH, and the reagent should be copper. The question may be like this in your mains and for your upcoming entrance exams like NEET, JEE, IIT, AIMS, like that. Okay, so please note down the name of the reactions and reagents. So primary alcohol is oxidized, vaporizing in the presence of copper, we get aldehyde, and secondary vaporizing, we get the ketone in the same reagent. In common process, the reagents are same. Okay, the next one is the from hydrocarbons. From hydrocarbons, the process is called ozonolysis. The process is called ozonolysis. Ozonolysis is the process is nothing but the adding of ozone. Ozone means O3. We are adding ozone to a hydrocarbon. Okay, let us check the reaction. I'm taking a alkene CH3 double bond CH2. The process is ozonolysis. So adding ozone, that is O3. And please note the product. The product is not an aldehyde. The product like CH2, CH2. Here we have 3 oxygen atoms. So one will be like this and the other will be like this. This is our product. And this is called ozonoid. Okay, this is called ozonoid. Then the ozonoid is again hydrolysis in the presence of zinc. Hydrolysis means adding of water. Hydrolysis in the presence of zinc, we get the aldehyde like 2HCHO plus H2O2. The byproduct is not important. So what happens when alkene is added with ozone? We get the product as ozonoid, and it is called ozonoid. The ozonoid is hydrolysis in the presence of zinc. The ozonoid is hydrolysis in the presence of zinc. We get aldehyde. We get the aldehyde and H2O2 as the byproduct. Is it clear?
Yes, sir.
Okay. And the next process, and it is from the hydration of alkynes. Hydration of alkynes. I'm taking a alkyne CH3 triple bond CH3. CH3 triple bond CH3. I'm hydrolysing it plus adding of water H2O. In the presence of concentrated H2SO4 and HgSO4 at 333 Kelvin. I get the product as CH2 double bond CH. Here it is. It is an aldehyde. I'm just rearranging it. So I got the product as CH3C. Here it is H and double bond O. Clear? It's an aldehyde. In the same way, I'm taking this is the first one. The same way, I'm taking another alkene, that is CH3C triple bond CH, adding of water H2O, the same reagents, that is concentrated H2SO4 and HgSO4, same Kelvin, that is 333 Kelvin. I got the product as CH3COH CH2. Just rearranging it, so I get CH3C CH3 double bond O. What is it? What is it? The carbon atoms bonded with alkene and alkene. two-side alkene. What is the product? Anyone? Anyone? Please answer. What is the product? Carbon atom bonded. Left side is alkane, right side is alkane. What is it? It's a anyone? What is this product? And what is this product?
It's ketone and aldehyde.
Which one is ketone?
The above one.
The second one is ketone and
Aldehyde.
first one,
Aldehyde.
first one is aldehyde. How will you
Yeah.
identify first one is aldehyde?
First there's alkyl group and hydrogen. Second one has both alkyl groups.
Yeah, that should be noted. Okay, the first I've already said that the first product, the one side is bonded with hydrogen atom, so it is an aldehyde. In the second one, the both sides are bonded with alkene group, so it is a ketone. Okay, please respond me, man. Follow this. Okay, so let us discuss. When I'm taking an alkyne, well, this is one type of alkyne is this. When I'm cutting this here, the two side will be like say CH3, CH3. Okay, so this is called a symmetric alkene. I think the bio students already learned that symmetric, bilateral symmetry, like that terms. Okay, symmetric means equal to half. When cut through the center, we get the equal to halves. Okay, then the second one is when I'm cutting through, like here it is CH3 and here is CH3, C. So it is unsymmetric. Clear? So when the symmetric alkane group is treated with water in the presence of concentrated sulfuric acid and HgSO4. What is HgSO4? It is mercuric sulfate. Okay, SO4 means sulfate, Hg is mercury. Mercuric sulfate at 333 Kelvin, we get aldehyde. Clear? And the same way, when the unsymmetric alkane group is treated with water, the reagent is say concentrated H2SO4 and HgSO4 in 333 Kelvin, we get ketones. Clear? Clear?
Yes, sir.
Okay. So these are the common preparation of aldehydes and ketones. So first is from primary alcohol oxidizing in the presence of PCC or chromium trioxide, we get aldehyde, and secondary alcohol is oxidizing in the presence of same reagent PCC or chromium trioxide, we get ketones. Clear? Second one, dehydrogenation process. What is it? When primary alcohol is vaporizing in the presence of copper at 573 Kelvin, we get aldehyde. And when secondary alcohol is vaporizing in the presence of copper, we get ketone. Okay, and the third one, from the hydrocarbons. Okay, from alkenes added with what? Ozone, we get ozonoid. When the ozonoid is hydrolysis in the presence of zinc, we get aldehyde. Clear? And when the symmetrical alkyne is treated with water in the presence of concentrated H2SO4 and mercuric sulfate, we get aldehyde. And when unsymmetric alkane in the presence of water, we get ketone. So this is from aldehyde alcohols, and this is from the vaporization of, this is from the oxidation of the alcohol, this is from the vaporization of alcohol, and this is from the hydrocarbons. Clear?
See